Alright, welcome back to what probably is a bad choice at this point. I mean, I haven't made an LPIC video today yet, so that's definitely needs to take priority. But I'm going to do another video on the book for Automate Your Network. So in between videos, I got these Nexus devices up and running. Needed to do some special things to get past that bootloader, but those things are all ready to go. So this video, I'm going to be trying to set up management access, so we can see we've got this management port. So we're going to use the AI, and we're gonna get management set up on here. Okay, so we're going to the AI. We're going to paste in the full show run. And let's say configure OB management on this device.
Advanced OOB management involves configuring the management interface, setting up routing if necessary, and ensuring that the necessary services, like SSH, are configured for remote access. Here is a basic step-by-step guide on how to configure OOB management on a Cisco Nexus device. Please replace the IP address and subnet mask with the actual IP information for your management network. Configure the management interface. Bash copy code switch hash config d switch config hash interface management 0 switch config if hash brf member management switch config if hash IP address 192 168 1 224 switch config if hash.
Alright, so looks good to me. Pretty easy. We do need to pick out our out-of-band management space. It looks like they picked out 192.168 .1.0/24. So that's fine. That gives us 254 addresses. We're not going to have that much. I'm kind of tempted to do. Let's do this. Let's do 10.0.0.0/16 for our out of band management address. So we're gonna drop it here. We're gonna do OOB MGMT. Out 10.0.0.0, and we'll do a /16 so that we have more room to grow. I mean, it's definitely overkill, but overkill is probably better than underkill. So okay, so now we're gonna set up out of band management on all 4 of our Nexus devices, and then we'll move on to the next devices. So I'm not quite sure how I want to do it. What about a DHCP server? Would you recommend using that for? Let me ask this. So what about a DHCP server? Would you recommend using that instead for OOB management networking IP addressing? I'm genuinely curious about this.
Using DHCP for managing IP addresses on your out-of-band OOB management network can certainly be a good option, especially in large networks where manual IP address management can become cumbersome. Here are a few points to consider. Ease of management. DHCP automates IP address assignment, reducing the manual configuration effort, especially helpful in large environments. Static IP requires manual assignment but gives more control and predictability. Address stability. DHCP ensure DHCP leases are long enough, or use DHCP reservations to ensure that devices always receive the same IP address. Static IP addresses are stable by nature since they are manually assigned and don't change unless reconfigured. Tracking and documentation. DHCP centralized management and logging of IP address assignments. Static IP requires external documentation for tracking purposes. Scale. DHCP more scalable for large numbers of devices. Static IP can become hard to manage as the number of devices increases. Security considerations. DHCP Use secure DHCP options and consider DHCP snooping to prevent unauthorized DHCP servers. Stag IP. Less susceptible to some attack vectors like rogue DHCP servers, but requires secure management practices. Troubleshooting and recovery. DHCP. Dependency on the DHCP server. If the DHCP server is down, new devices may not be able to join the network until it's restored. Stag IP. No dependency on external services for address configuration. Recommendation. For smaller environments or critical infrastructure, you might prefer the control and stability of Stag IP addresses. For larger environments where ease of management and scalability are priorities, DHCP with reservations for critical devices can be a good choice. If you opt to use DHCP for your OOB management network, ensure that your DHCP server is reliable, securely configured, and that you have a mechanism in place for tracking DHCP reservations and leases. Finally, regardless of whether you choose DHCP or Stag IP addressing for OOB management, always ensure that you follow best practices for security and documentation.
So what are the best practices for security and documentation?
Ensuring the security and proper documentation of your network is vital for maintaining its integrity, performance, and manageability. Below are some best practices for security and documentation. Security best practices. Network segmentation. Separate different types of traffic, such as management, production, and guest traffic, into different VLANs or networks. Implement access control lists, ACLs, to restrict traffic between segments as needed. Firewall protection. Use firewalls to control inbound and outbound traffic. Keep firewall firmware and rules up to date. User authentication and authorization. Use strong, unique passwords for all devices and accounts. Implement multi-factor authentication, MFA, where possible. Assign the least amount of privilege necessary for users to complete their tasks. Secure protocols. Use secure versions of management protocols, SSH instead of Telnet, HTTPS instead of HTTP. Secure SNMP with strong community strings or SNMP3. Patch management. Regularly update and patch all network devices, servers, and applications. Remove or disable unnecessary services and features. Intrusion detection and prevention. Deploy intrusion detection systems, IDS, and intrusion prevention systems, IPS, to identify and mitigate threats. Regularly review logs and alerts. Incident response plan. Develop and maintain an incident response plan. Conduct regular drills to ensure readiness. Security audits and assessments. Conduct regular security audits and assessments. Address vulnerabilities and weaknesses promptly. Documentation best practices. Inventory management. Maintain an up-to-date inventory of all network devices, servers, and applications. Include information such as device models, serial numbers, firmware versions, and IP addresses. Network topology diagrams. Create and update network topology diagrams. Include details.
All right, that's not super relevant right now, and we can't really do a lot of that in the lab. So let's enable SSH, or let's get IP addressing. Yeah, which we have. Yeah. All right, so we're gonna start with the two core switches. Oh, I don't even need a. Yeah, it's saying default gateway should be here. We don't even need a default gateway. I guess technically it would be like um here, like on Axis 1 or whatever, so that we can NAT it. We can have a first hop redundancy protocol there. I don't know, man. I'm getting a bit too tired to continue as well. If this is just like a 10-minute video, I might upload it regardless, but I don't know how much I can really get done. Let's try setting up SSH on it. Okay, so we should have instead of username, we should have something like public key or something like that. So look for K B C D E F G H I J K L M N O P. So it's up pretty high. H I J K. So I see key. Um, that might be something with SSH. Let me try that. Oh, we do have something with SSH. So SSH. Okay, this is to generate a key. So this is username password. But I don't think we need a password. Okay, so that's not working. The VTY lines. Let's see how that looks in the show run. Okay, we do have VT lines in the show run. But we don't have transport import SSH. Which is kind of interesting. I don't know what to do. Oh, I see. Okay. Okay, so let's do username gposh and then SSH key. Okay, and then we need the SSH key from this automation server here. Oh, you know what? This is kind of rough because we don't have shared clipboard, but we can do the same thing we did with the SSH server. So we can do Python -m or Python 3 -m gdp.server. Okay, and then we can do uh, 1.4 800. I think that works. Is this 1.4 even? Oh, it looks like it's 1.5. So let's try it again and try it at 1.5. Okay, there we go. So now we got the public key right here. Okay, it looks good to me. Oh, okay, cannot extract the information. Okay, so I do need to, I think, create the user. Oh, hey, look at that. That worked. Brilliant. Okay, wonderful. Now, of course, this isn't right, but IP address, but it's kind of too much to change right now. So yeah, we can add that to all of them. If I do a show run, uh, so the VRF context, I'm missing the default gateway, but we shouldn't need it because we're just gonna uh, communicate on our own network. Uh, I mean, we could have it, which would be kind of nice, but I'll put that on there later. Right now, I'm really happy with this. So don't forget the copy run star. That's the most important thing. All right, now let's move on to the next switch, which will be dot two. Oh, and I gotta be careful because that's not the right IP for my lab. There we go. That looks a lot better. We could try knowing this out. Juniper, you can have multiple, so just to be safe instead of sorry. Okay, we're not gonna deal with the default route for now. Perfect. It's working really well. And then I think that's, oh, we do need to do the transport input SSH. But we are missing that, so I'm not sure exactly what to do with that. Um, maybe go into the VRF somehow. So like VRF context management. Alright, there's really nothing there. Okay, so we just got the copy run start, and then we're good to go. Okay, so let's take care of the other Nexus devices. So this is dot one, this is dot two. We'll make this dot three, dot four, 5, 6. Yeah, so we'll just go like layer by layer pretty much. So the next is so we did the core layer, so we'll do the distribution later. So we'll do we'll start with this one. Alright, 10.0.0.3/24. Shut down. Exit. Alright, I'm not going to worry about the default gateway for now. Oh, that's interesting. The user already exists. And it is the correct switch. It's kind of fascinating that it already exists. Oh, it looks good to me. We can't do the line VTY. So last step is to do a copy RS. Alright. So if we do a show run pipe section, we can do it on management. Okay, so that's good. Pipe management, so we see the IP is on there. Looks good to me. So let's do .4. And I will have to cut the video sometime. Probably do the rest of them off camera because it's just a lot of kind of boring stuff that doesn't really change from the device to the device. So it doesn't matter to do it on or off of the camera. And if you wonder, like, why are you doing this all manually? Why aren't you automating this? Well, you know, this is what I'm talking about. It's like, so 1, 2, 3. So this is 4. It's like, you know, not everything can be automated. Like this will be a person in the data center, like plugged into the device, and it's like, you know, we need these. Now, is there something you can do with DHCP options? That would be cool. That would be really cool. That would be so cool. I really kind of want to figure that out. Yeah, I think that'd be cool to use DHCP options. So, is there an option for ZTP? Uh, the thing is, if that feature is not on the device, then we're kind of screwed. Let's have a conversation with the AI. We finished the Nexus devices, which I kind of wanted to get through because those are kind of tricky sometimes. So we gotta finish the distribution. So the distribution, we've got 1, 2, 3, 4, 5, 6, 7, and 8 on the distribution. But let me have a. So this act of configuring user accounts, enabling SSH, and configuring management IPs on the device. If I want to automate this somehow, how can I do that?
Autumn. Aiding the configuration of user accounts, enabling SSH, and configuring management IPs on network devices can be achieved using various tools and scripts.
Can it though?
Here are several methods and tools commonly used for automation and network management.
But see, that's therein lies the problem because, you know, what are you going to connect it to? I mean, therein lies the problem because you you say that you can connect to these devices and just run an Ansible playbook against them, but literally what we're trying to configure right now is the IP that you would use for management access to these devices. So they just straight up don't have any sort of IP that you could target using Ansible. Is that correct? Like, what do you mean you can just use Ansible to configure this stuff? I thought this was like a prerequisite to Ansible. Like, I don't understand how your answer is correct when we haven't configured basic network things yet.
You're correct, and I apologize
Yeah,
for any misunderstanding. In order to use network automation tools like Ansible, the devices need to have network
exactly.
connectivity and should be reachable over the network.
But that's what I want to
This means that an initial
automate.
configuration, including setting up management IP addresses, needs to be done manually or through some other means before you can automate further configurations or management tasks using Ansible or similar tools.
Okay, here we go. This
Here are
is
some
good.
alternative methods for automating the initial setup. 1. Zero-touch provisioning, ZTP. Many modern network devices support zero-touch provisioning.
Perfect.
With ZTP, devices are configured automatically when they are powered on for the first time. A DHCP server provides the network information and the location of the configuration file, which the device downloads and applies. 2. Pre-staging configuration. If ZTP is not an option, you can pre-stage the configuration by applying a base configuration, including management IP, manually or using a console connection before deploying the device to the production network. 3. DHCP and dynamic DNS. If the devices contain an IP address via DHCP and register with dynamic DNS, you could potentially reach them using their DNS names to perform the initial configuration. 4. Console servers. Some organizations use console servers that provide out-of-band, OOB, management access to network devices.
Right.
This allows remote access to the device console port for initial configuration even before IP connectivity is established. 5. USB configuration. Some devices support loading the initial configuration from a USB drive. This can be used to load the base configuration, including management IP,
Right.
username, and password, to enable remote access for further automation. Once the initial configuration is done and the device is reachable over the network, you can use Ansible or other automation tools to apply further configurations, updates, and perform management tasks.
Yeah, that's a good option. So this is a good answer. We don't have ZTP on this. I know that the Arubas have it. Yeah, pre-staging is another big thing. That's pretty common. I like the DHCP and dynamic DNS. I really like the third option, DHCP and dynamic DNS. Please explain this more and explain how I can apply this to my lab network in GNS3.
The DHCP and dynamic DNS option can be a convenient way to set up initial network configurations for your devices. Here's a step-by-step guide on how you might apply this to your GNS3 lab network. Step 1. Set up a DHCP server. Add a DHCP server to your GNS3 topology. You can use a router with DHCP capabilities or a dedicated DHCP server like DNS Mask, ISC DHCP server, etc. Connected to the same network as the devices you wish to configure. Configure the DHCP server. Define a DHCP pool with a range of IP addresses. Set the default gateway, subnet mask, and DNS server. Optionally, configure options for TFTP server or boot file for further automation. Step 2. Set up a dynamic DNS server. Add a DNS server to your GNS3 topology. You can use bind, unbound, or another DNS server solution. Connect it to the network and ensure it is reachable by the devices in your workstation. Configure dynamic DNS. Enable dynamic DNS updates on the DNS server. Set up a zone for your lab domain. Configure DHCP to update DNS with the hostname and IP address of each client. Step 3. Configure network devices for DHCP. Set network devices to obtain IP via DHCP. For each network device in your GNS3 topology, configure the management interface to obtain an IP address from the DHCP server. This can typically be done through the device console interface. Set hostname on devices. Ensure each device has a unique hostname. The DHCP server will use this hostname to register the device in the DNS server.
How can you automate step 3 to configure each management interface to pull an IP from the DHCP server?
Automating step 3 can be accomplished through several methods. Here are 2 approaches. 1. Using a configuration script. If you can access the device console upon boot, either via console port or through out-of-band management if available, you can use a script to automate the initial configuration. Here's a simple example using a Python script with the Faramiga library for SSH.
This is good.
2. Using a configuration template. If the devices support it, you can use a configuration template like ZTP, zero-touch provisioning, where the device, upon boot, downloads a configuration file from a network server. Create configuration template. The template should include the necessary commands to configure the management interface for DHCP.
Yeah,
Shell copy code interface management 0.
So we don't have zero-touch provisioning on this. Unfortunately, I wish we did. Does a Nexus 9500 have zero-touch provisioning?
Yes.
Oh, it does? How do we do
Cisco
it?
Nexus 9500 series switches do support zero-touch provisioning, ZTP. ZTP allows you to automatically configure the switch upon boot up without manual intervention. The switch, when booted with factory default settings, will attempt to download a configuration file or a script from a designated location, typically a DHCP-provided TFTP, FTP, HTTP, or HTTPS server. Here's a simplified overview of how you might set up ZTP. DHCP server configuration. Configure a DHCP server on the network where the Nexus 9500 switch can contain an IP address.
Yeah, I definitely need that.
The DHCP server should also provide options for the location, URL, of the configuration script or file. Configuration file, script. Prepare a configuration file or a Python script with the desired settings and host it on the designated server, TFTP, FTP, HTTP, or HTTPS, so that it is accessible by the Nexus 9500 switch upon boot up. Switch boot up. Boot up the Nexus 9500 switch with factory default settings. The switch will attempt to use DHCP to acquire an IP address and locate the configuration file or script. Automatic configuration. The switch downloads and applies the configuration file or executes the script, thereby completing the initial configuration process. Verification. Verify that the switch has been configured correctly by accessing it through the management interface or console and checking the running configuration. Remember to refer to the official Cisco documentation for detailed steps and best practices when implementing ZTP on Nexus 9500 switches.
Okay. So how do I configure... Oh, I probably have to be in configuration mode. I can probably do a show ZTP.
Given the CLI options you provided, it seems like the specific commands related to zero-touch provisioning, ZTP, are not directly listed. However, this doesn't necessarily mean that ZTP is unavailable. The commands might not appear directly in the root level command line interface, or they might not be explicitly labeled as ZTP. On Nexus 9500, ZTP is typically enabled by default and will start automatically when the device boots with a factory default configuration. If the switch does not have a startup config and is connected to a network with DHCP, it should attempt to use ZTP. Here are general steps to set up ZTP on a Nexus 9500, considering typical options for configuring ZTP, even though they are not explicitly listed in the provided CLI. Ensure ZTP is enabled. Since you don't have a direct command listed, make sure the device is in a factory default state. ZTP starts automatically if no startup config is detected. DHCP server configuration. On a server or network device acting as a DHCP server, configure a DHCP pool for the Nexus 9500. Define options to provide the location, URL, of the configuration script or file. Typically, this is done using DHCP option 67 for the file name and option 66 for the TFTP server address. Prepare configuration script. Write the necessary configuration file or script, typically Python, that the switch will execute. Host this file on a server that is reachable by the switch, TFTP, FTP, HTTP, HTTPS. Connect and boot the switch. Connect the Nexus 9500 to the network with the DHCP server. Reboot the switch, and it should automatically attempt to use ZTP to obtain its configuration. Verify configuration. Once ZTP has completed, log into the switch and verify that the configuration has been applied successfully. Check logs. If available, use show logging or equivalent commands to view the logs and verify the ZTP process. If you are unable to find a specific ZTP configuration commands or if the process does not start automatically, I recommend referring to the official Cisco documentation for the specific Nexus 9500 model and NXOS version you are using, as there may be variations or additional steps required based on the hardware or software version. Additionally, consulting Cisco support or community forums can also be helpful in resolving any specific issues related to ZTP on Nexus 9500 switches.
Alright, so that could be a cool option. Basically, what I'd like to do with this series is make sure that absolutely everything is automated, so that all I have to do is go to my lab, and if I want to build on another floor, I just drop everything down, and it's already built out. There's nothing I have to do. So even the act of now obviously you can't really automate plugging in a port, but the act of giving that management IP address, that's automated too, and we can do that with DHCP. So, yep, that's it for this video. Thanks for watching, and see you in the next one.